our speaker tonight, Jason Horner. He's based in Colorado, and he's principal over at JJH Consulting. He's focused on the Azure Data Platform, where he works mostly in the data and analytics, advanced analytics spaces. He's a Microsoft certified master. And with that, I'm going to go ahead and turn things over to Jason.
Now we're rolling. Okay, much better. Anyway, so now we're all set. So let's get rolling. So we're going to talk a little bit about some data lake key concepts. There's a ton of slides here, so I'm going to talk through a lot of this stuff, and there's some textual stuff that you guys can look at afterwards. That's more kind of reference based, but I just want to have that all out there. And then I'll do some very light demoing through the portal to walk you guys through some different storage account configurations and give you some kind of tips and tricks for working with Azure Storage as well. So the big concept here is the data is kind of the new currency, right? So over time, organizations have collected more and more data. Initially, it was fine just to store files locally on a server, maybe on a hard drive or a file share, or even somebody's local machine. Think about Excel spreadsheets and Access databases, things like that. As data volume improved and it became more kind of, key to the organizational success, key to running the business and making decisions, we need to start thinking about different ways to treat it. So like with money, if I have a little bit of money, I can keep it in my wallet, right? If I have more money, I keep it in a safe. And most people, not all people, but most people, when they have a lot of money, they start using a bank, right? And so the data lake really is your kind of bank vault. And so this is how we're treating our data as a corporate asset, right? Because it's valuable. It's valuable to the company, to your organization, to solve problems, to talk about what was past performance, what potentially does future performance look like. And the data is a little bit different than other things, right? Technology comes and goes. When I started working with stuff, I was on Oracle 8i and Access databases and moved to SQL Server 7 and then, or 6.5 actually, and then 7, and now we're on 2019, but I do a lot of my stuff in Azure as well. Those technologies have all changed, but that underlying data from back in 1997 or 96 is potentially still valuable to the business. So however you decide to store that data, you really want it to be agnostic and separate from how you're computing, right? And so data lake is a big enabler about that, and it has some other characteristics. So we'll talk about those as well. So again, like I said, the key thing is, data volumes are going to grow over time. It's only going to get bigger. So we need that cost to be as minimal as possible to keep as much data online, right? So with that, it needs to be scalable, not only from a size or volume standpoint, but also from a performance standpoint. If I process terabytes of data, it should take roughly along the same time as if I was processing gigabytes of data. If we're talking about running queries, aggregates over the data, right? Obviously, a terabyte is going to take longer to process than a gigabyte, but running queries over that data, you should get linear performance, right? As the data size grows, your query response time and the time it takes to do things should show that kind of straight line linear pattern. Cost should be linear as well, right? It should, if I was talking SQL Server back in 2005, storing 2 to 5 terabytes of data was an expensive proposition, right? It was either JBODs hooked up to the server, it might have been a SAN or a NAS, right? Depending on those systems add a lot of cost and complexity. So we want something that's very simple and that can grow on demand. And the other thing too is if you think about storing data in a database, you have to define that schema up front, right? And then if new requirements emerge or situations change or the data feed evolves, you've got to go back and do a bunch of retrofitting before you can even get the data loaded. So we want to use something called schema on read, where we're just, I hate to say the word dump, but we're basically just saving the data in the data lake without necessarily knowing exactly how we're going to use it and not having a clearly defined schema on it, right? And we'll talk a little bit more about that concept as we go through the day. So just kind of another way to look at it, right? We want it to be interoperable. So whatever we use for our underlying data lake, it needs to interact with as many services. Those could be Azure services, they could be GCP, they could be AWS, right? And different types of sources, right? So relational, structured RDBMS type systems, streaming systems like Kafka, IoT systems, right? All sorts of different systems that maybe weren't as prevalent, 5-10 years ago. Again, it needs to be performant, supports different access patterns, so analytical patterns, as well as, ad hoc kind of trickle feeds, things like that. Scalability, it needs to be linear and infinite, right? I don't want to not be able to load data because I'm still waiting on new disks to come up, right? I need to be able to secure it, right, and govern it. So I need to be able to have some kind of access controls on that. So ACLs or roles can help with that. It needs to be manageable. I need to have an API and open interface that I can interact with it to do management functions. So that's really what we're looking for in a good underlying data lake characteristic. So let's look through kind of some of the options that we have, primarily in Azure, right? There's other clouds have other options like S3 buckets and things like that, but this is primarily Azure. So the first thing is just a standard blob storage account. This is the Windows Azure Storage blob. It's an object store, right? So it's a flat structure. There's not a concept of folder and directories. You have a URI, which represents a path to the contents, right? It's optimized for unstructured, so it's primarily built for doing, writing data out to it and pulling it back, not necessarily updating or modifying the data. I can usually a modify is basically a new write and then a delete of the old version, right? There's no in place writing on the data. It's going to be lower cost, right? It's definitely cheaper than traditional Azure Data Lake or Gen 2. And there's lots of storage tiering and there's lots of different things I can do in here. Now, this works in a lot of your current applications here, and there's some features that you can only get with Blob Storage. So things like soft delete, change feed. So there's still some reasons to use Blob Storage, and it is cheaper. So especially if you're dealing with an unstructured data, this might be a way to go, at least as part of the overall data lake architecture. But generally, this doesn't work well for analytical workloads, right? So Microsoft introduced Azure Data Lake Gen 1, which I wouldn't recommend using anymore, but it had some good capabilities, right? So it had the POSIX ACLs and Azure Active Directory integration. So Windows Blob Storage was primarily based on storage keys or SAS tokens. There wasn't the ability to control more fine-grained access, right? So it's more coarse access. Lots of driver support, so all the major big data platforms, the MPP systems, can interact with it. It's optimized for analytic workloads. There's no file limit. Back in the day, and I think this still may be the case, there was a limit of about 2 terabytes for the size of a file in Blob Storage. And then there's a folder structure, right? So rather than, if I want to move a file, rather than copy the file to the new location and deleting the old version, I can just update the pointers just like in a Unix or Windows file. So it's much more efficient there. But the problem was they're basically, you had 2 different kind of types of storage accounts, and they didn't provide a clear kind of seamless overlap in functionality. So what they did is they introduced Azure Data Lake Gen 2, which is basically just a storage account with a specific configuration. And I'll walk through all this as a demo. But this supports, deep integration, different types of APIs for doing different types of things. So if I want to work with it like a blob storage account, I can do that. But it also has what's called the HNS, or the hierarchical namespace, which allows me to layer that folder structure and do atomic file operations on top of it. Cheaper pricing, support for tiers. So ADLS Gen 1 didn't have tiers and support for that. Didn't have a premium mode, right? So there were a lot of limitations there, and better performance overall. Okay. So with that being said, let's just look through the portal, the Azure portal real quick. And so this is the Azure portal, and I'm just under storage accounts, and I'm just in the create new. So there's a couple things I want to call out, right? The first thing is, as far as storage account names, you're pretty limited. So they have to be globally unique because it ends up being a URL, and it's got to be only lowercase letters and numbers, and it's got to be between 3 and 24 characters. You always, with every Azure resource, you always give it a region. Note that that can be a different region, but shouldn't generally be from the region, or sorry, the resource group where the resource group lives. Okay. Now, this is an important concept because this has a financial impact as well as a performance impact. So if I'm doing a Gen 2 account, I need to choose between standard performance and premium performance. You know, generally what I'll do is in the development environment, I'll go with standard, and in the production environment, I'll go with premium. There's a cost difference here. It's not like thousands and thousands of dollars, but it's depending on your overall data volume, but you're going to get better performance using premium. Okay. And then you also need to pick a redundancy level. This also has an impact on cost. So generally, for a data warehouse workload, I go with LRS. It's the least available of all these options, but it's also the cheapest. So, you know, that's a pretty aggressive approach. Some people, especially if you have very high uptime requirements, you might want to go with one of these other tiers, right? So we're not going to dive too much into these, but there's lots of documentation around that. The other thing you need to understand is, okay, how do I actually create a Gen 2 account? And that's really this dialog here. So as soon as I hit this enable HNS, I've got an Azure Data Lake Gen 2 account, right? So that's going to enable the ABFS driver and the multi-protocol support. So notice now I can't choose SFTP as an endpoint, which is this is kind of a new feature. So in some cases, I may want to create a landing zone in my data lake, and I'll talk more about what that is. But basically, I want an external person to SFTP files to me because maybe that's the protocol they support. I don't want them writing directly to my data lake. I might actually set up a storage account Gen 1 and put it on SFTP. I could also do a NFS as another option, and I have Azure file shares. So SMB, NFS, and FTP are all good options or potential options for a landing zone, which we'll talk about, which is kind of a component of a good data lake, or can be a component of a data lake. So networking, we've got a couple options here. Generally speaking, I go with public, but for higher security environments, I'll set up private endpoints, which is a point-to-point connection where the storage account isn't addressable from the internet, right? So with public endpoint, the URL is addressable from the internet, but it can be protected by either a firewall and it's also protected by Azure role-based security as well as ACLs, right? So it's not, if I just turn this on, like not anybody can get to that storage account. Now, if I turn on, where is it at here? If I turn on enable blob public access, then I can set up a read-only public file. And in some cases, there might be a reason to do that. If you're a data provider and you make some of your data available for free, like for example, Microsoft has all their demo data as open blob storage accounts, that might be a reason to do that. But generally, you want to turn that off. And then there's some options for data protection. Now, most of this is relevant more for blob storage and not Gen 2, but some of this capability is kind of interesting, like the ability to soft delete, to put archival processes in place or rules, enable versioning, right? Enable change feed. But you can see a lot of this stuff turns off with when you enable HNS. So there's a little bit of a trade-off there. And that might, some of this functionality may, either from a compliance standpoint or a feature standpoint, may tip you into using a Gen 1 account just to get some of these features, especially if that data lake's being shared with an application that's making heavy use of unstructured data. And then I have some encryption options. We're not going to dive too much into that. So that's pretty much kind of how you would go about creating a storage account. So I would just configure it the way I want with the right redundancy, the right performance, and then I would just create the resource and it would show up in Azure. And then I can browse it. So I'll show you guys kind of just really quickly. So here's what it would look like. So you can see all the options I have configured, right? So you can see I'm enabled HNS. So that means it's a Gen 2 storage account. I don't have files set up. Now, the other thing that's important to understand about these storage accounts is at this point I've provisioned a storage account. I then need to create containers, and you can see there's some already here. So within this storage account, there's a container, which is, you can basically think of it as a root file system. So I can copy data from demo to DLS, those are both containers, via like AZ copy or some other utility, but I can't use like a file management, like a copy command. The root of this file system is demo, right? I can't, these aren't subfolders necessarily, even though they can appear like subfolders. So something to keep in mind there. One question I often get is, you know, how do you go about deciding whether I need another container or another storage account? So there's performance quotas at the storage account level. So that might be a reason to scale out. You might have a situation like, for example, if this was a dev storage account, I may create containers for each of my developers so that they can work with the data in their, you know, they can have a copy of the data and they can work with it without kind of stomping on each other. Kind of like how in a good development environment, you'd have every database developer would have kind of a local copy of their database. Maybe not with all the data, right? Just maybe with the data they need, or maybe a full set of data, just depends on what the scope is. So that's one way of doing it. Some people might use these to create zones, right? And I've also seen architectures where people will say, okay, well, I have a prod container, a dev container, and a test container. I'm not a huge fan of that. For certain environments, it might make sense. Generally speaking, if I'm going to set up dev, test, and production, I'm going to create 3 different storage accounts, right? So there's not a really huge cost factor there. It just keeps everything nice and clean and separated. The other thing to note too, and we're not going to talk about this a ton, but there is a table API. Generally speaking, probably should avoid this, but you might have legacy apps that were written to use this. A good replacement for this would be something like Cosmos DB. Supports kind of that same API. There's also a queue. Again, that's more of an app consideration thing. If I was needing to pull data out of a queue, I would look at services like Kafka or Event Hub or Service Bus, things like that. And then file shares. So here's where I can actually create an SMB file share. I'm just going to do one real quick because they're pretty easy. So I'll give it a name and I'll call it inbound. So what's interesting is this ends up actually looking like an SMB file share. And in fact, if I click over here, and if I'm on a Windows machine, sorry, I'm in the wrong place. Let me go back to that. Let's see, connect, there we go. So this is pretty cool. So if I run this script from a PowerShell command prompt, it'll actually mount this, it'll create a Z drive for me that has this mapped, right, with the security set up, assuming there's no firewall blocking. There's actually a pretty cool PowerShell script out there that tests for connectivity problems here. And I can use storage account key or I can use Active Directory. So that's actually newer since last time I've looked at this. I can also have the same script for Linux or Mac OS. So if I was working locally, let's say I'm using a MacBook or something like that, I could actually run this and have this mounted directly to my machine and copy files in here without needing a tool like Storage Explorer, which I'm going to show you in a minute. Now, what's cool about this is it basically allows other users, maybe I have old on-premise technologies, SSIS could be one of them, or other ETL tools that only need to know how to talk to file shares. They don't know how to talk to Azure Storage. Then I could use those copy commands to move the data into Azure here, and then I could use something like ADF to move the data from this into those containers here. It's important to note that while this is in the same storage account, this is a completely different file system than any of the containers that I've set up. Okay. We'll talk about some of the different access and security towards the end, but I just kind of wanted to give a high-level review of kind of storage accounts and how they work. There is a tool that I recommend using. It's a Microsoft tool. It's Azure Storage Explorer. And what it allows you to do is browse the storage account through kind of like this this little UI. So here you can see I'm connected to that same storage account. I've got a few files in here, right? And I can do things which I think are pretty cool. I can go to get properties of the file and I can copy the URL. Notice that this is the blob URL. So this is using the WASB protocol, the WASB. And then the DFS is going to be using the HNS, or the hierarchical name format. And so depending on what type of code I'm working with, I may need one or the other URL, right? There's also some metadata about the stuff, or sorry, about the file that I can see in here. And then another cool thing I can do is I can get folder statistics. So this will actually scan it and tell me, okay, I've got 6 blobs, and this does it recursively and tells me how big the data is here. That's super hard to see, so let me just call that out for you guys. So that's interesting. The other thing that's kind of cool is if I want quick ways to get some of that, like I can download, I can copy, I can upload, but I can also copy the URL and copy the path. So that's handy. A lot of people don't know about that, so I just want to call it out. The other thing is if once you start working with a lot of these, like you can see I've got lots of different subscriptions and lots of stuff going on. I can actually right click, and generally I won't do it at the blob container level, and I'll show you why. So if I right click this and say add to quick access, it's going to pin it underneath here. But notice, like, this is a case where I've got DLS pinned, but I don't have any idea what storage account that's associated with until I actually click on it, and then probably find out that this looks like this is actually one of my clients. But I can figure out the storage account by right clicking on the URL and working out the storage account name, but it doesn't tell me here, right? So if I pin the storage account, at least I know the name of the storage account. So that's a little tip for this. And you'll also notice this list can get quite big in a large enterprise subscription. So this is a very useful thing to pin stuff to quick access and scan stuff. Okay, so that's a high-level overview of Storage Explorer. I can connect to all sorts of different storage accounts. It doesn't, I can connect to. You can see I've got multiple different subscriptions that I can hook into. I can use SAS tokens to authenticate. I have a whole host of options here, right? So different types of connections that I can make here, and there's some wizards here to help you with that. So anyway, with that, I'll take a quick pause. I know that was a lot of information, but just if there's any questions on that, now's a good time to ask away. So let's see, we went through all that. So the other thing we need to understand before we start architecting our data lake is really understand our data sources and the different types of data and how it arrives and what the latency requirements are. So to start off, I want to think about how is that data arriving, or how am I processing the data? So batch typically means that, every hour I'm going to process the data, and I'm going to process it kind of in a batch mode. That's more of a traditional ETL, ELT kind of approach, right? And so this is going to drive potentially the technology and how I store files and things like that. So I need to understand that. And then if I'm using something like Spark Streaming or just Spark, it uses more of a micro batch pattern, which is basically batches so small that it appears to be streaming. So that's a consideration. And then I do have a true streaming format where I'm actually processing the data as it arrives, right, over time. So things like Azure Stream Analytics, different use cases. So if you think about like call centers, they have some great use cases for different types of data, right? There's batch reference data about the customer, about the services they're subscribed to. But then they have kind of two types of metrics that they generally do. Historical metrics, which would be, over the last month, what was the average hold time for a customer, right? But then they also have current metrics that are based on the current state of the system. So not in the last month, but right now, what's the average hold time, right, of all the active calls that are going. So there's a concept of an evolving event where as the call is working through states, right? You're on hold, then you're talking with an agent, then maybe you go back on hold, then you talk with an agent, and the call gets terminated. Once it gets terminated, that's considered historical, right? while it's in progress, that's a streaming scenario, right? Because we need to actually analyze that data while it's still live. And so that's where we would use something like Kafka or Azure Stream Analytics, so on and so forth. So it's important to understand what types of data and what the latency is around that data. How stale can that data be, and where the business can kind of still get value out of it. So that's one aspect, right? It's kind of a vector, because the other side of it is what types of data. So we have structured data, which is just traditional RDBMSs, right? That could be Postgres, MySQL, could be Oracle, could be SQL Server. Then you have semi-structured data providers, lots of like software as a service, REST APIs, right? Things like Cosmos, Azure Functions, web applications that are generating data, custom applications that are generating telemetry. So, those could be in various formats, could be stored in a database backend at some level, but when it gets pushed out to you, it's semi-structured. So it could be in JSON, it could be some other kind of textual file format that's maybe not tabular in nature, like EDI files, XML, those types of things, right? And then we have event source data. So things like IoT Hub or Event Hub or Azure Stream Analytics, where we're dealing with a stream of data coming in, or even Kafka, right? And so the way we deal with that data can present some challenges, but generally speaking, like as that data comes in, we want to also ingest it to our data lake and store it in a way that's going to make it more easy to analyze, right, and manage and deal with. As far as ingesting data, I've got lots of different services that I can use, right? So I can use things like Azure Data Factory or SSIS, can ingest data. There's other ETL tool sets, right? Airflow, Luigi, right? There's all sorts of open source frameworks to do that. There's simple things like AZ copy, right? So if the requirement is, hey, I get a file and I just need to move it somewhere, and I don't need to do any processing on the file, like a weblog. Part of that could just be using AZ copy or distcp if I'm on a Hadoop cluster to copy the data from point A to point B, right? If I'm just moving the data around, or maybe I'm just moving it to an alternate location for backup purposes, right? So don't overlook these two tools just because they seem simple. So the answer isn't always, need to use a full-blown ETL tool, but sometimes it is. Older tools like Scoop, right, which is a Hadoop tool for ETL. The other vendor ETL tools, so the Talon, Medallion, Fivetran, mentioned Airflow, lots of different tools out there. Probably some newer ones that I'm not even familiar with. I tend to be a big fan of Azure Data Factory because it's an Azure native service, right? You can create Airflow clusters and set those up in Azure, but you're going to be rolling your own code, or not your own code, your own infrastructure, right? So using Azure VMs or Docker containers or Azure Container Services, you can do that, right? But it's a little bit more work. So I like Azure Data Factory. I can just configure it, set up my sources and connections, and build my pipelines, and I'm off and running, right? Not as robust from a dynamic standpoint as something like Airflow, which is based on Python code, or even SSIS, which has very robust expression languages, right? So tons of other ETL products out there. And then as far as data types, we talked about semi-structured and relational data. We also have unstructured data. So all data really has structure, but when we talk about unstructured, we're just really saying, hey, it's not rows and columns, right? We're saying it's free text, it could be PDF, it could be image files, it could be in a binary format that supports structure like Excel. And then we have the semi-structured formats like CSV, JSON, XML, and custom kind of proprietary formats, things like EDI or, different industries. Like I did a lot of work in the railway industry, and they use train files of different types that show activity and do car hire accounting. So medical billing has, some kind of common file formats. Each industry has their own kind of interchange formats. So those are all things. And the reason this is all important to understand is, when we get this data in one of these formats typically aren't optimized for analytics, right? Like the last thing I want to do is run a bunch of analytics on top of raw JSON files. So probably the first step in my ETL process is to copy the file as it is and put it somewhere. and then do further processing on it and dump it out either into a relational database or Cosmos DB or a Synapse SQL pool, or potentially out to a Parquet file, which is more optimized for analytics, right? It's more structured. It's got indexing. It's tuned for running repeated queries on it. So something to consider. There's also some big data formats, which I kind of alluded to a little bit. So I'm going to go through some of the stuff because we talked about this. So generally speaking, like a text CSV is going to be the most ubiquitous as far as, I can open it with Notepad. I can make sense of it. It's human readable. But with that comes a lot of problems. I can't count the number of hours I've spent trying to debug non-standard CSV files, right? With different types of escaping, different quoting, different character sets, byte order marks, all this stuff, right? So, it is what it is. JSON, very interoperable. You're seeing this, or I'm seeing this a lot these days, both from getting it from like REST APIs and just in general, vendors and applications are providing JSON feeds. So it's kind of becoming the more default interchange model. It's pretty cool. There are some limited data types there. It is human readable. It supports complex types, so things like arrays and nested objects. There's two flavors of JSON. There's single line JSON and multi-line JSON. So single line JSON means the entire file is a valid JSON record. And to process it, I loaded it all into memory. And then it may have arrays in there or nested objects, and I can run queries against it. Multi-line JSON means each line in the file is a JSON record, right? And so the strategy I use for processing those two types of JSON files is a little bit different. Most of the big data processing frameworks can support both of those modes, right? So Spark. AVRO is something that I can get from message services, things like Kafka, other places. What's kind of cool about AVRO is it stores schema, so it has support for schema evolution, which basically means the attributes that I get today may not match the attributes that I get tomorrow. But if I query data from yesterday and today and tomorrow, it all kind of rationalizes and makes sense. Sounds a little magic-y and hand-wavy. In practice, it basically just means if the field isn't there, it returns a null, right? There's a little bit more to that, right? But that's it. It is a binary file with a JSON schema, so you do need a custom viewer utility, so it's a little more opaque. You have Apache ORC, which is kind of a older format. It's definitely still favored. It's columnar format, so it's very similar to like Parquet. It has support for compression, predicate pushdown, lots of different things. Supports does not support complex types, so no structures, maps, lists, or unions. So you don't see this a ton these days, but there's probably some legacy environments, especially if they were running Hadoop or Hortonworks, you might see more ORC. Parquet is kind of where everything's standardized. It's kind of the default, I'll call it the best format for storing data in a data lake for, well, I'll say that with a caveat. For storing data for analytical purposes, it's a columnar format. I think of it as just like clustered column store index in SQL Server. So there's support for compression, predicate pushdown, maintain statistics. The downside to this is the writes are slower, right? Not by a ton, but there's definitely some overhead there. Whereas text file, it's just going to write it out. Anytime you add compression and things like that, it's going to be some overhead. So something to consider. What you're really seeing a push towards today is to just make everything Delta Lake. I'm not a huge fan of that. I think it definitely has some purposes. I think vendors like Databricks have really tried to make this kind of a differentiating feature. So you also hear a lot with Delta Lake of this kind of lakehouse architecture, which to me is really just a logical data warehouse, which just means that basically you have a data lake and you've put some amount of governance and some structure around it, some rules around it. And so now you can kind of treat it like a relational database. This doesn't mean, like the lakehouse doesn't mean that the dimensional model is going away anytime soon, right? That's still the best format for data analytics, in my opinion. I also think that, there's still a lot of use cases for using tabular models, right? Whether that's Power BI or if that's Azure Analysis Services in tabular mode. both of those technologies still have a good run life cycle ahead of them, right? What's cool about, so one thing with Parquet is if I've got data that's streaming and I need to update a Parquet file, I've got two options. I can either write the new records out to another file and then solve it at query time, or I can take the new records, read in the old records, perform the transformation in memory, and then rewrite out the whole thing, right? So that's not optimal, obviously, if I'm supporting really low latency streaming. So that's really where Delta Lake comes in, because it supports the CRUD operations. So read, updates, deletes, and inserts. Now, it does have ACID transactions only at the table level. So I can create I can have transactional consistency across a single table, not across multiple tables. And then the other cool thing is, in addition, under the hood, it's all Parquet, but there is kind of this transactional log concept, which, among other things, enables you to do time travel. So I can say, tell me what this Delta table looked like yesterday. And as long as I haven't pruned or vacuumed out that history, I can look at that data, right? And there's some schema enforcement and evolution. So because of all these attributes, Databricks is really pushing this as kind of a default standard to store the data. The main problem, in my opinion, with Delta Lake is that if I don't have a Databricks cluster running and my data stored in Databricks, for example, I can't query that Delta Lake file. Now, other tools like Azure Data Factory can read Delta Lake. Synapse Spark pools start to support Delta Lake. So there's starting to become more support for it in the ecosystem, but it's not quite there yet, and there's still a lot of caveats and limitations. So it's important to kind of think about, depending on how I'm going to use that data, do I really need Delta Lake, or can I use Parquet, right? Or should I use some other file format? So it's important to understand the trade-offs here. We'll talk a little bit more about that. A little bit on Lambda architecture. This really isn't the focus of the talk, but the idea to me, when I think about Delta Lake, it was really built for this streaming hot layer, right? Is because the data is evolving over time. I need to be able to stream the data in and update those files and then have consumers see that data right away. There isn't room for the latency of Parquet data. But if my data is immutable, which is kind of an interesting concept, right? If it's an IoT data coming in from a sensor, I get a reading every 1 minute. That reading's never going to get updated, right? Once that sensor sends that data, it's not changing. I could just batch that out to Parquet, right? Now I'd have a lot of small files, which we'll talk about, but there's ways to manage that. So point being, Delta Lake isn't the only game in town. There's still use cases for Parquet, but Delta Lake does definitely make some things easier, okay? So when we start thinking about data lakes, we also need to think about how we're going to structure it or how we're going to lay it out. So again, this is a case where, in addition to the Lakehouse, Databricks has really kind of pushed this medallion architecture, a bronze layer, which is where you store the data in its kind of rawest format, lightly cleansing and filtering and augmenting or enriching your data in a silver, and then a gold for business level aggregates and kind of more your user-facing data. So this looks really familiar because this is basically like your ETL flow, right? Sources over here, a staging layer, and then a model layer, a data warehouse layer. Or it could be ODS, right? Staging, and then data mart or data warehouse. And then all your analytical tools are still going to sit on top of that. I'm not a huge fan of this. I mean, as far as it goes, it's fine, but I like something that's a little bit more robust. So I kind of prefer this type of a model where I have very specific zones that do specific things. And these tend to just be folders, right? And so there's not a ton of difference, but it's more intent, right? So my raw data, there's some rules there. It's always going to be immutable. I'm only going to write the data. I'm going to store it in general in its incoming format, right? I'm not going to modify the data. If that data is in a non-structured format, I may create a structured zone where I take that data. Let's say it's an XML file. And let's say that XML file is compressed or zipped up. So what I would do is I would take in my temp layer, I would copy that zip archive, I would unpack it, and then I would take the underlying XML file and copy it into my raw. Then I'm never going to touch that again unless I need to archive it. Then I would convert that XML into a structured format that could be CSV, it could be Parquet, it could be Delta Lake. I'm going to fix some of the data types. So, you know, if there's string, you know, XML is kind of untyped a little bit. So I could put, you know, create date and time fields and strings and so on and so forth, but create more of a tabular structure. Now, if I'm going to take that data and load it into a data warehouse downstream, I'm going to take whatever's in there and write out the current, what I need to load into my data warehouse into a stage zone. So the stage and the temp is really a working area, and the stage is saying, I've processed all the data and I'm ready to move it to the next phase. So these are both transient layers, meaning that the data is there for a short time, but it gets removed. Whereas my raw and structure are persistent, meaning that once data is in there, unless I'm going through an archival process or there's some business rule or compliance reason, data is going to stay there forever. Okay, which is great because then that means I never have to go back to my source to go back and see what happened with the data. And if I add new columns, or if I start out, let's say I get a 100 column file and I only process 6 or 7 columns from it, and 3 years later they say, well, actually we need these 15 columns, I just go back to my raw file and reshape kind of my downstream layer, and I'm off and running. Okay. The two other zones that I use is a curated zone. So that's going to be my logical data warehouse or my data lakehouse. I really don't like that term, but it's data that's shaped either specifically for data science teams, right? So it's a more flattened table with just the data that they need for a specific use case, or it's a more flexible dimensional model, right? So it's a star schema, which, you know, different files for dimensions and facts. The ref zone is going to be really similar to raw, though the difference here is the intention. Raw is coming from a system and it's transactional data. This tends to be more of our master data in the ref zone. Lookup codes, things that the business manages that they use to decode stuff. So if you think about an ERP system, an ERP system will store general ledger transactions and codes, right? That's all in the transactional system. What those codes map to aren't always stored in the way that we need it. So we introduce mapping tables or spreadsheets or lookups, right? So think about anytime I do a VLOOKUP or any kind of lookup operation, that's all reference data, right? And so I have a zone for that. And the main difference here is that I give the users ability to upload new files here and manage this. I keep more tighter control of this because this is more intrinsic to my pipelines and my automated processes, right? Now, you can obviously change, you know, relax or make those rules more strict to fit your environment. Two other zones, we already talked about the landing zone. I typically only use that when I'm working with somebody that's outside of my organization and they need to drop data to me via FTP, SFTP or NFS or SMB file shares, whatever the case may be. Those are generally partners, right? Or maybe services that I subscribe to. There's also Azure Data Share, which I'm not going to talk about, but that's the opposite of that. So landing zone can be for landing data in and pushing data out, rather than giving somebody that's external to my organization access to my raw zone or my curated zone. I may take like a nightly dump of a curated table. Like let's say, you know, I'm running a fulfillment company, and for each of my clients, I need to give them all the orders that we shipped out of our warehouse yesterday. I could dump that data out into the landing zone and they could pick it up and they could ingest it into their systems, right? So think about this as being data interchange, right? And then the archive zone is if I needed to move the data out for any reason, compliance reasons, or archive it off for cheaper storage. Maybe I only need to keep 10 years of business data online, but I don't want to lose, you know, that data if somebody ever wanted to go back to it to do some data science or something. The other concept here is I might, one of the kind of issues with data lakes is that there's no real backup if you're using Azure Data Lake. So if I go in, there's backups from physical corruption, right? If the Azure storage goes down or something happens, but if I go in and I'm a privileged user and I delete the file, it's gone, right? With the older Blob Gen 1, I can put on soft delete and I can put some policies around that, but with Gen 2, you're out of luck. So you have to like manually copy the data off to a more secure, either a container or another storage account to get that redundancy if you really need that, right? So this is just basically what I just spent the last 5 or 10 minutes talking about. This is just calling it out in text, right? And the different use cases. So I'll just go through these kind of quickly. I'm not going to even talk about them. It should be the same. Pretty much covered all this stuff. So temp, yep, curated, archive, subzones. So within our raw zone, we might have subzones. So and those are just folders as well. So a folder for each system. So let's say I'm getting data from Dynamics and let's say Salesforce. I would create a Dynamics subsystem and a Salesforce subsystem. And then within that, each of my objects would have their own folders. And then if the volume warranted it, I would further partition that data, which we'll talk about in a second. Usually that's by time, location, or potentially both, depending on what the business scenario is. And it's just a way of splitting that data out to optimize analytical queries and storage space. Oops, what the heck am I doing? Users, so I might create zones for users, kind of a rare thing, but if I have a data science team that just needs a place to put data, I could set them up with their own zone or their own container where they can play with data or do development tasks. Talk through these other data lake zones, so that's kind of redundant. So the key thing that I talked about earlier was really that the fact that that data is going to outlive a lot of these technologies. So, you know, let's say 10 years ago, Hadoop was really the only game in town, right? And, you know, Spark wasn't necessarily a thing. Flink certainly wasn't a thing. Synapse wasn't a thing. Databricks wasn't a thing, obviously. But as time changes, my data, I still want to use that same data, and I don't want to have to throw away that structure or move it around. You know, I have massive amounts of it. I want to operate on that data where it sits. And so these different MPP engines will come and go, right? So things like Kafka is used for working with log data at scale. Synapse Analytics actually has 4 different pools, right? So I have a Spark pool where I can run workloads similar to Databricks, right? I have a serverless pool, which supports T-SQL, but allows me to query the data lake directly without doing ETL. I've got dedicated pools, which is the old SQL DW, and then I've got the new Data Explorer pools, which is more meant for logging and telemetry data, and under the hood uses the Azure Data Explorer storage engine, right? So same thing that runs log analytics and Kusto. You can get in Synapse if you want to store your own event data. And then obviously you have Databricks, and there's things like Apache Samza and all sorts of other kind of, you know, more fringe technologies that you might run into. And a ton of NoSQL solutions as well, but generally they have their own storage engines. So some other patterns to think about. In addition to the zoning, I would say getting the zoning right is really what's going to help you prevent the data swamp for the most part. But just having a consistent file naming structure. And I like to, even though this could potentially be redundant, I like to keep this unambiguous so that if I copy this file out of the folder, that I know exactly what's there. I also notice I'm using the date encoding in here, so I know when that file was generated by the name, so that has some benefit. It really just, by making it proper and consistent, it's going to aid in self-service and make the database more usable. Partitioning, so this is a key thing. You're not necessarily going to need to do this for all or go to this level for all of your files, but for example, here I've got my raw zone, and then I'm using this folder naming with a name value pair in it. And what certain technologies like Hadoop and Spark to some extent, as well as serverless pools can do, is they can say, hey, you use DB, so I'm going to put an attribute in this, a virtual attribute called DB, and I'm going to assign it this value AW for all the records in this folder, right? Same thing here for schema. And then I can also do filters based on this. I can do traditional kind of wildcard filters, but even some of the query languages will understand, like if I ran a query that was like aggregate all my sales for year 2021, it's not even going to read this folder, right? So it won't even have to scan those files. It'll know to do the elimination on it. So that can be helpful. So generally speaking, I'll partition my transactional tables. I'll at least create a folder. I don't want to mix folders for different types of objects. So if I have a sales, customer, and product table, I'll have 3 folders. They're all under the AdventureWorks database. So I have schema equals sales, and then the table will be sales order, table equals customer, table equals product. The sales order will have an additional level of partitioning based on the time. And to what level I go down depends on the volume of file, because I want to optimize the resulting file sizes as best I can for processing, right? Which typically, depending on the size of your data, means somewhere between 128 megs, if it's smaller data, or a couple gigabytes, 10 gigabytes, if you're dealing with terabytes, right? Because you don't want to have, you want to balance between thousands and thousands of little files, right? Over partitioning versus one big file that may or may not be able to be operated on in parallel. You also want to avoid creating empty folders and, like I said, mixing file types within a single folder system. Okay, splitability is a good concept to understand. So certain file formats are splittable, which means that if I store all the data in a single file, the MPP engine can go in and push parts of that file out to different nodes for processing, which increases parallelism and increases performance. But when I add compression, that can sometimes break that. Or if I'm dealing with a file format like XML or single line JSON or certain other file types, they're not splittable, right? Whereas a CSV file is splittable, right? CSV with no compression is splittable. Parquet file is splittable. So if you're using a non-splittable file format, that's okay. It just might mean that you use more manual partitioning, right? So in the case, if I have a bunch of single line JSON files, I may split those out by, say, site and by year and day and month, right? So that when I go to process a year's worth of data, I'm processing 300 files instead of one big giant file, right? Or whatever the case may be. Compressibility, so whenever you do compression, you're basically trading off, right? And so it's important to understand that some columnar file formats like Parquet and ORC have their own internal compression, but can also use additional compression on the file itself. So for example, Snappy is an example of that compression. And you're trading off, anytime you do compression, you're trading off CPU time for disk IO, storage space, and network bandwidth, right? So you want to do some testing to make sure the compression is giving you the benefit that you want, right? So columnar formats are best for things like I said, Parquet or Delta Lake or ORC are best when the data is going to be queried multiple times because it supports column elimination, has that internal compression, it supports predicate pushdown, it maintains statistics so you can get better quality query plans. And it can also be used to work around encoding issues that you see with delimited file formats. This was especially true in parallel data warehouse, where you're dealing with, for example, text files with different datetime formats or nulls in them and inconsistent encoding. Dumping that into Parquet can kind of sometimes work around all those issues. So just something to think about. Lots of anti-patterns. So the data swamp, you're not organizing your data lake effectively. You've got multiple file types in a single folder, or the folder naming, there's not a consistent pattern. It's not broken up into zones. Inconsistent file naming, use of bad file types or improper file types, right? So Excel or whatever, just inconsistency there. There's another key thing is there's no governance or data catalog. So that's really the trick to making a data lake be kind of self-serviceable, right? To allow users to access that data lake and get data out of it without needing a lot of hand-holding or support, is by having a data catalog that says, here's what's in our data lake, here's how you access it, here's the tools that we support, here's the file formats, here's our data dictionary, right? Here's some sample data, here's the known problems with the data, all those kind of things. And then governance around who can access it, what can they do with the data, really supports the veracity when you think of the big V's, right? Small file problems, so this happens a lot with Delta Lake really works around this pretty well, but where I have lots of small files. So think about, I'm getting telemetry from a machine in a warehouse. it's generating it every 5 minutes. It gives me like a file that's like 3 or 4 kilobytes. What I would do here is if I can use Delta Lake, great. I'll store that, move those files into Delta Lake. But what the problem is if I ever want to query those small files, I'm gonna have to scan through thousands and thousands of files. So what I can do is I can create a batch job to go through and aggregate all those small files into a single larger file. So maybe every night I run a process that takes all the 5-minute files and creates a single daily file and dumps that in the raw zone for optimization purposes. Again, different compute engines are going to have different guidances for the right kind of size or chunk size, and it's going to scale with your data size. So generally speaking, 128 megs is what you should shoot for. But if I'm working with a terabyte file, my optimal partition size is going to be different than if I'm working with 100 terabytes of data. So if I'm working with a terabyte, the right partition size may be around 100 gigs, right? Maybe 200 gigs. If I'm working with, a file that's 100 gigs, it may be around 200, 500 megabytes, right? So it just depends. But there's definitely some minimums to think about, right? So just doing testing with it and doing with your query workload is going to lead you to the right answer in that case. Lots of challenges, right? So lack of a schema or descriptive metadata can make the data hard to consume or query. How do you assess the quality of the data going into the data lake? This is a huge problem with initial older data lakes. That kind of when that architecture first started coming out, people were just dumping data out and saying, well, the report writers will figure it out, right? So they weren't checking to make sure that the ETL pipelines were running correctly. So you had a lot of changes in formats or just bad data. So there should always be a process that validates the data to make sure that it's suitable for purpose, right? The veracity again. You got to have governance, access control, especially with things like GDPR and the California privacy legislation. You need to be able to remove users' data from your data lake, right? If they request you to do that. So you need a process to set that up. If the data is already relational, like if I'm just taking data from SQL Server, there may be no need to put the data in the data lake, right? I tend to, these days in my architecture, I use data lakes where I would have used staging in the past. But if the data is small enough and it's a simple enough system, I could just continue to use the old pattern of, load the data into a staging zone or staging schema inside my data warehouse and then create my dimensional model based on that staging layer, right? So it doesn't have to be in a data lake. The data lake, the nice thing is it's cheaper than storing the data relationally. And now we have compute engines that you can run T-SQL queries against it or Spark SQL queries. So that's pretty helpful. The data lake by itself doesn't give you what you get from a dimensional model or even an enterprise data warehouse, right? So you still need that dimensional modeling. You still need to understand how to present the data to the user. And then the other thing is people might just store the data in the data lake that's never used, right? So if the data doesn't have a useful purpose or there's no need to use that data, you're just wasting a bunch of time and money and space, right? So things to look out for. So there's different data catalogs. This is a little bit older slide. There's Azure Data Catalog. Nowadays we have Purview, right? But the key thing here is you want to be able to search and discover your data sets that are in the data lake. You want to have metadata at your fingertips about that. You want users to be able to contribute to that documentation and add comments. So kind of information experts and SMEs. And you want to be able to just document it, right? So there should be an online shareable data dictionary, right? That's the basic underpinning. That's like V0 of your data catalog is just a data dictionary with a schema. So that as a query report writer or a business analyst, I can connect to it with Power BI or Excel or Tableau or any of these other tools and consume data from the data lake without needing IT to become involved, except to get me access to it, right? So a little more about data catalog. These are really the key things, right, that I want from a data catalog. So can I use the data? How can I join this data, right? Or can I even join data from different data sets? Who's who's the expert about this, both from a technical standpoint as well as from the standpoint of understanding the data and how it relates to each other, like from a business standpoint. Who's the administrator who can let me get in to the data? What's the lineage? Where did this data come from? What was the source system? What transformations were performed on it? And then quality, can I trust the data, right? Adding metadata to files in your data lake, like a created date, process date, MD5 hashes of your data, all kind of add to the veracity of the data lake, which is important. And we're kind of coming up on time. We've got a few minutes left. So it's important to understand in Azure, there's different ways to connect to the accounts. In Azure, you have basically these different types of security principles or identities. So a user is like Jason at jasonhorner.com is a user. A group could be, data lake readers is a group that I can define in Azure Active Directory. Service principal is an Azure concept. It's basically like a service account that has a key associated with it or a secret that if I provide that identity and that key, I can get access into it. So it's not tied to a specific user. It's something that I could share with multiple users or services. And then managed identity is really the Azure service itself has an identity. Like Azure Data Factory has an identity that doesn't require storing a secret anywhere, that can be assigned access to. So once I have these principles, I can then assign them rights into the storage account. So here's how, for example, I can just use the access keys, but this is very coarse grained. If I use these access keys to connect, number one, it's not best practice, right? So these should only be used for administrators, or if it's the only way that it's supported. I wouldn't give these out to other people. I might consider letting an application use one of these, but I would try to find a better way. But this gives you complete access to the storage account. It doesn't even check ACLs. So once you authenticate with the storage account, you have complete total control to it. The next best level of security is shared access keys. So in this case, I can define what I can do, how I can do it, and the time frame. These are typically used when you're giving access to somebody outside of your Active Directory or potentially a service. And so you generate this SAS connection string, you send them that secret, and then they use that to connect, and that gives them the rights. Again, this will bypass the ACLs too, so it's more of a coarse-grained. So like I give it read access, but I can't say, oh, you can only read this folder. You can read the storage account, you can write the storage account, or you can delete from the storage account, but I can't get any lower grain than that. And then we get to Azure role-based controls. So the standard roles, owner, contributor, reader, user access administrator. This is to the storage account itself and not necessarily the underlying data, right? With the exception of owner. Owner always has full access to the underlying data. It's mapped to a super user inside of the data lake account. There's resource specific roles. So storage blob data owner will bypass the POSIX ACLs and maps to the super user account, much like the owner account, right? Storage blob data contributor. This is generally what I recommend you give things like Azure Data Factory or Synapse Analytics. This gives them the ability, those services, the ability to read, write, and delete blobs within the container. Again, if I assign you this role and I assign ACLs to you that say, hey, you can't read from this folder, you're going to be able to do it because once, I can't make it more. I can't make it less. Sorry, I got that backwards. You can't make it less restrictive. So I can further restrict this storage blob data contributor role to specific folders. But what I can't do is through the ACLs, I can't give you storage blob data reader and then give you write access via POSIX ACL. It doesn't work that way. So this would be giving me read access. If I wanted write access on a folder, this wouldn't work. What I would have to do is if I wanted write access on a single folder, I would give you storage blob data contributor and then give you read on the folders that I want you to just have read on. POSIX ACLs are just Unix permissions, so I have read, write, and execute, and those can be granted to a user or a group or any of the credentials that we looked at, credential types, so service principals, managed identities, so on and so forth. So, you know, I have the ability to read, I have the ability to write. There are some kind of nuances, like it's not like NTFS, so I need read and execute all the way down to be able to list the contents of the folder. And if I want to be able to create new items, I need to have write and execute all the way down. And if I want to traverse, I need to have execute. So there are some kind of nuances there that you have to understand. So different scenarios
Hey, Jason.
here. Yeah.
Real quick, do you have time for a question, or would
Yeah,
you like
sure.
to shelve it? Oh,
No, yeah, let's go.
Sure. So, so Nick Cellini had a question. Are there any concerns with expiration dates of files in ADLS?
So as far as like, I guess I need more clarification. Like, are you saying like you want the file to expire so that it's no longer valid, or I wonder if he's talking about like the SAS token.
You're welcome to unmute, Nick, by the way.
Is there a case that it would live in the ADLS past its expiration, or?
Yeah, so that's kind of that archive layer, right? So if there was a compliance requirement that says, hey, we don't want to keep any data older than 7 years, we're gonna have to build a process to move that data out and either delete it, because a lot of places they really do want you to delete it, or in some cases it's more of a business requirement, so it's not useful to us generally after 7 years, but we still want to maintain it just for auditing purposes, so we'll move it off to another storage account. So those scenarios can come up with, and then obviously, like if the data is out of date because you grabbed a full extract from a SQL database yesterday, and now you've got new data, you have to work out a merge process there, right, to apply your changes. Does that help?
Yeah, that helps. And I know in S3 as an alternative, you set an expiration date, and you got to make sure that it goes somewhere before it expires.
Yeah. So, and that's something. Let's look at that real quick, because it's a good question. It's actually because it's one of the things that might lead you to. Let's see where that is. It's. So there may, you know what, maybe it's, you can set up a policy. There's a way to put, and I'm not seeing in the UI, and I haven't had to do this in practice much, but there's a way to configure it so that you say, hey, I'm gonna associate a policy with this folder to say anything in here after 3 years, automatically archive it off to cool tier, for example, right? Or automatically delete it after 90 days. So you can set those policies up to control it. If you just search for storage account, so here's the documentation. Let's see if it comes up. Here we go. So there's time-based and lifecycle management policies. So those two things, but they only work with blob storage. Those will get you that kind of level of automation, and that's helpful because then you don't have to roll your own solution, right? But again, it doesn't work with the Azure Data Lake Gen 2. But this could, lead you to choose the blob storage instead. So really good question, actually. And that's all. I say newer, right? So I built this presentation, gosh, maybe 5 years ago. Some of that stuff wasn't even there, right? So some of that stuff is more recent. So for example, when I built this session originally, Gen 2 storage was still in preview. It was just coming out of preview. So things have evolved, and there's definitely some updates I need to do. And add more content, but you can see I've already got a ton of stuff in here, so it's kind of tough. So with that, I can turn on a firewall, right, which gives me some additional security to only let certain IPs connect to the storage account. And with that, we're kind of right on time. So I kind of went through the data lake, like I kind of showed you the zones and stuff. So I feel pretty good about that. So
Great. Well, thank you so much, Jason.
Yep.
Again, yeah, and yeah, thanks as always. And thanks everyone for attending this evening's user group meeting. And we look forward to seeing you all again.